Hello everyone. I'd like to introduce our work Blurry boundary delineation with semantic aware feature learning. Deep neural networks has largely improved their segmentation performance. However, the encode-decode based networks cannot accurately delineate the Blurry boundaries. After analysis, we think it is because the further information in the encoder layers. We propose that learning high-resolution semantic features is a potential solution. Specifically, semantic-aware encoder feature learning can endow these networks with high-resolution semantic features, and thus can well handle the blurry boundary delineation problem. And this blurry boundary delineation is very important, but it is very challenging. So let's say these examples. Okay, in the left is a periodic MRI image, in the right is CT periodic data. We see that the regions connecting the bladder and this prostate is quite unclear. And also, in the CT images, these regions between the three angles are all connected, and it's very hard to distinguish them. Let's also revisit the previous encoder-decoder architectures. The first one is fully convolutional networks. Yeah, in the encoder layers, it can provide high-resolution information because there are a lot of spatial details there, but it's poor at semantic information. In the decoder layers, it can provide rich semantic information, but it is poor at low-resolution information. So another encoder-decoder network, UNet, provide a skip connection to connect the information between encoder and the decoder. And it can provide accurate location information for clear boundaries. Here is an example of clear boundaries for this bladder prostate rector. Yeah, but it cannot provide accurate location information for blurry boundaries. Yeah. So let's analyze more about it. How for example, a physician handle this kind of situations. Because experts have prior knowledge, so it can manually annihilate the organs, even if it is the blurry boundaries. So we want to distill this kind of prior knowledge to the encoder-decoder networks and propose that learning high-resolution semantic encoder features is a potential solution. Particularly, we have two solutions. One is using high-resolution pathway. Another is semantic guided encoder feature learning. Let's first visit our first methods. High-resolution pathway. Here is this typical UNet architecture. In the skip connection, we place the high-resolution pathway. And besides this kind of segmentation tasks, we also place our boundary recursion task to further improve the boundary delineation. We want to learn high-resolution semantic feature for the blurry boundaries with this HRP. How the HRP can learn this kind of high-resolution semantic features? Let's go to details, okay? First, we use a dilated residual block, and the semantic information can benefit from the larger context because dilated residual block can provide a lot of bigger receptive field, and at the same time we retain the resolution information. So that means that we can provide a lot of details. So in this way, the high-resolution semantic features can be learned. There are several advantages. First, it can learn discriminative high-resolution semantic features, and also can finish the distilling prior knowledge implicitly. However, the disadvantage is also very obvious. First, cost a lot of GPU memory, and also it will bring a lot of more parameters, making the training cost more data. So let's visit our second solution, semantic guided encode feature learning. Yeah, we want to learn the high resolution semantic features at a low cost. Let's introduce semantics from the decoder to guide the encode feature learning, because decoder can provide semantics and the encoder is good at resolution. Why not just introduce semantics from decoder and help the encoder feature learning? And we propose such a module called semantic guided module as SGM. Similarly, we also provides boundary detection tasks as auxiliaries. Differently that we provide a clear boundary detection and a blurry boundary detection. Clear boundary detection here is bladder and rectum. Blurry boundary detection is prostate. So let's visit how we can implement or design this kind of semantic aware encoder feature learning. We can see here it is a typical decoder and encoder. We see that the encoder feature maps is very good at the details, but the decoder feature maps are very good at the semantics. So let's provide the decoder semantics to the encoder. Combine them together and then provide an aggregator to fuse these informations. Specifically, we design our channel-wise encoding and our spatial-wise encoding. For example, this kind of channel-wise encoding is the typical spatial channel attention, which can learn that among this kind of encoder feature maps, which should have higher weight and which should have lower weight. And then we apply this weights to the encoder feature maps in a global way. The spatial wise encoding is a typical spatial attention. And we can say that it can provide spatial details. Which regions are more important, which regions are the organ regions we should focus on. And then we apply this kind of spatial attention to the encoder feature map. And finally, we aggregate these two kind of feature maps so that we can achieve high resolution semantic features. And then we finally provide it to the decoder so that we can finish the encoder feature learning and learn high resolution semantic features. The advantages are very obvious. First, it can learn discriminative high resolution semantic features and also display prior knowledge explicitly. And it costs just a subtle increase of parameters and GPU memory. And it can provide faster convergence. The limitation is also obvious because it is quite sensitive to annotation precision, because it is depends on the annotation precision for the organs or tissues. So let's compare the first method and the second method, HRP and SGM. We can see that both of them can learn high resolution semantic features. And we conduct some visual comparison on the periodic MRI dataset. We can see that our methods with HRP and SGM can provide the best performance for the prostate regions, because prostate regions are the most blurry ones. And we can also, from this kind of 3D visualization of the residual errors, we can see that our proposed method is much better than the compared widely used segmentation methods. Then the quantitative comparison on the public periodic dataset validates that our proposed methods can achieve the best performance. Then we show the visual comparison on the more challenging dataset, I mean the periodic CT dataset, we can say that our proposed methods can achieve better segmentation, I mean delineation for this prostate. Yeah, because we can say actually it is quite challenging. And from this residual error 3D maps, we can see the proposed methods, I mean HRP and SGM can show much better performance. And this kind of quantitative comparison once again validates that our proposed methods can achieve better performance. Yeah. So here are the takeaways. We think that escape connection in the encode-decode networks cannot perform well for the blurry boundary delineation, and we proposed high-resolution semantic features was a solution. Two following methods are proposed. One is high-resolution pathway. Another is semantic guided encode feature learning. Yeah, and both of them can handle the blurry boundary delineation much better. Thank you.